Hello, my dear friends. Welcome to the third chapter or a third part of the UPS video series. So, in this video, we are going to understand how the double conversion uninterrupted power supply functions. So, let us get into the topic. So, here we are going to first see the block diagram representation of the double conversion online UPS. In this double conversion online UPS, we are going to have a rectifier or charger unit, and we are going to have a battery, and we have inverter. So whatever the load requirement here, whatever the load requires, all the power is going to pass through these two units in a normal mode of operation. The AC source will give the power to the rectifier unit, and the rectifier unit will convert the AC into DC signals, and this DC partially will be stored here in the battery, and remaining power will be transferred to the inverter. The inverter will convert the DC into AC, and this AC will be given to the output devices as per the load requirement, the magnitude of the voltage, and also the power factor. Everything will be controlled here in this inverter unit. And if you see the stored energy mode, you can see in the red color dotted lines. When the utility power fails, when there is no utility power available, then the power flow will start from battery through the DC link to the inverter unit. The inverter will convert the DC into AC, and this AC supply will be given to the load. In case of failure of the battery or any stable condition, that time the static switch is going to be operated. So the total power from the AC source will be fed through the static switch to the load. So what you can understand from this discussion until now is the load consumes the power from the AC source through two units, that is rectifier unit and inverter unit, in a normal mode of operation. So we convert AC into DC and DC into AC. That's why it is called as double conversion UPS. In case of power failure, the DC is converted into AC in the inverter and it is fed to the load. So that means 100% of the AC source will be converted into DC, and again the DC, the total DC power will be converted into AC power, and it will feed to the AC load. So we are going to see there is a little detailed block diagram here. So we have a AC input, we have in EMI filter here, electromagnetic interference filter, and there is a relay to turn on and turn off, DPST relay, and we have a AC to DC double booster, so which is nothing but a rectifier and voltage boosting device. Once the AC supply is given to this double booster, so you will have a voltage which is required to feed the off bridge AC inverter, DC to AC inverter. Also partial amount of power will be transferred to the charger unit. According to that, the battery will be charged. So the power flow would be in two directions, one to the load through the inverter, and the second one through the battery through the battery charger. So this is a normal mode of operation. And when the utility power fails, when the utility power is not available, that time the battery start discharge the energy through the DC to DC converter. So that means the available DC voltage will be increased or decreased as per the requirement of this bus link. After this, buck or boost operation. Then off bridge DC to AC inverter will convert the DC into AC signal, and this will be fed to the load. So what is the magnitude required for the AC output? That will be determined by the pulse width modulation, which is given for this off bridge DC to AC inverter. And what is the voltage required in the DC bus link? That will be determined by this DC to DC converter, so it is nothing but a buck boost converter. And how much battery charging is required, charging current, how much charging current is required, whether it is charged fully or it needs to turn off, or so that kind of operations, everything will be taken care by this charger unit. So this AC to DC double booster is going to rectify, also it will boost the voltage, so that DC bus link voltage is enough to feed the DC to AC inverter. And we are also having a power factor correction control circuit here in the input side. So this is the block diagram representation of double conversion unit. Now let us see as a circuit how it functions. So this is a circuit diagram of a double conversion unit. So first we will see in a normal mode of operation how things is going to happen. When the AC supply is available, the power flow starts through the filter unit and it goes to the voltage doubler unit, also the rectifier unit. So the current flow follows this path as I am drawing now here. It goes to the this point, and same time it also allows the current flow in this path. So across this capacitor we are going to apply this potential voltage in the positive up cycle. In the negative up cycle of the input, the power flow goes in the opposite direction. So from here until here, and then at the same time the power also flows through this path. So across this capacitor, so it is going to come like this. So across this capacitor we are going to apply in the negative up cycle. So this is how the voltage doubler unit and the rectifier unit allows the current flow during the positive and negative up cycle. So once this work is done, AC to DC conversion is done, we have the DC at the DC link bus. Now we need to convert this DC into AC with the help of inverter unit. So we have two IGBTs here. So these IGBTs are going to triggered with the controller unit. So let us assume that the IGBT 1 is triggered first. So the now current flow takes place in this way. In this way, so the current flow takes place here. Once the required time is finished, so this IGBT is going to be off and the second IGBT is going to be on. Now the current flow again from the same point, it goes in the opposite direction in the second inverter and comes back to this point. So you can see the current flow direction is opposite in each IGBTs are conducting, so that we achieve the AC signal. and required magnitude will be controlled by controlling the IGBT's duty cycles. So based on the duty cycle, the magnitude can be controlled. Okay, so also we have a filter unit so that it will have a smooth output in the output side. So this is the normal operation. We give a AC and we convert into DC here, and this DC is going to be available in the DC bus link. From here the inverter is going to convert this DC into AC to the load. At the same time, also the battery need to be charged. The battery need to be charged. So from here, from the VAC input, it is also given to charger unit. So here it is a simple rectifier unit, bridge rectifier, and again the charging rate is going to be controlled by using this IGBT, which is available here. Now during the positive cycle, this diode will conduct, the current flow would takes place like this, it will go back like this. So this is a positive cycle, and the negative cycle, the current flow will start from here, it will go to this diode and it will go out like this. So it is very normal bridge rectifier operation. Now you can see here there is no direction change because we want a like this output, rectified output, not a AC. So of course when it is going through the filter here, we have a filter here, and it is going to reduce this ripples. And also we have a transformer unit here. So this transformer unit is going to also like it is going to act as a forward converter. So this forward converter will allow this, the whatever the available signal here will be transferred to this secondary part. And from here we have a filter again, and direction, we have a diodes to limit the reverse current flow, and it goes to the battery here. Okay, so this is how the battery charging unit functions. So now I explained about this, and also I explained about this battery charging unit. Now let us see how this battery discharging unit functions. So when the power supply is not available from the utility, now the battery discharging unit needs to feed the power to the DC bus link, and from there the inverter will take the power to the load. So this DC P, that is positive point, will be connected here, and this negative point will be connected to this point. So when the utility power is not available, so this unit is going to feed the power to the inverter. So now let us see how the battery is going to discharge. So here we have a push-pull converter. So this is a push-pull converter arrangement. Push-pull converter. Here again we are going to see how this push-pull converter works when the switch 1 and switch 2, so let us name it as switch 1 and switch 2. When switch 1 is operational, how it is working, and when the switch 2 is operational, how the things is going to work. So let us see when the switch 1 is functioning. When the switch 1 is functioning, or let us take so this is switch 2 and switch 1. Yes. So from here we are going to feed to this transformer, two transformer coils. When this switch 1 is functioning, so the power is going to flow through this path, and it will go here, go through this, and it will come to this, side. At the same time, the power flow will takes place in this path. It will come back like this. So it will add up. So two path current will be added at this junction, and it will go to the switch. It will go to the battery negative side. So it will start from here. It divides here. Partial amount of current is passing through the upper portion of the transformer coil, and it is coming back. And similarly here, the remaining of current of which is flowing through here, also upper portion of the transformer coil, and it is coming back. It is added at this junction, and it is returned to this switch 1 through this coil. So when the current flow is flowing in this part, there is a induced voltage here, and this will be fed to the DC link with the help of these rectifying units. Okay, now again during the other switch, when the second switch is functioning, so let us take the other color. When this switch is functioning, we will erase this. When the second switch is functioning, S2, so the current flow comes here, and also the current flow should go to this portion. So these two current is getting added up here, and it will go to the return line. Okay, so let me make it clear. See, it was big, I couldn't able to draw it clearly. So let me take a thin pen. So the current flow is, we need to conduct in the second switch. So it will go through here, it will come here, and same time will go here, it will come in this direction. These two is added up, and it will go to the negative terminal of the battery. So now again this portion of the coil and this portion of the coil is going to induce the voltage, and respective rectifier unit or a diode unit is going to deliver the power to the DC bus link. So here we can see it is connected here. So that means it will go through this diode, through this one, and it will go back to the DC negative point, and it will come back. Okay, so similarly here when it was feeding here, it will go through this path. Okay, so this is how it is going to discharge the battery energy to the load through the push-pull converter. Hope it is clear. And so whatever I explained here is given here in the explanation part. As per the IEC standards, the input independency, these characteristics, it is voltage and frequency independent, because we are going to have a inverter where you can control the frequency, also the required voltage in the output side, irrespective of the input voltage and frequency. Voltage output waveform, both are sinusoidal, because in supply is coming from the utility side. That time also the double conversion is taking place, so the inverter is going to feed. During the battery mode also, the inverter only going to feed the load. So both cases the inverter can provide the sinusoidal output. So yes, dynamic output performance, this changeover, the time, how much time it is taking, so there is no interruption. So that's why it is given number 1. There is no interruption, and during sudden inclusion or removal of load, so there will be a voltage fluctuation, so maybe up to maximum 10 milliseconds of time. Okay, so with respect to that, it is defined as 1 1. So this is about the double conversion principle in the UPS system. Thank you. Hope it is clear. If you have any doubt, please let me know in the chat box. Thank you. Thank you so much.